Sometimes your output power requirements may not be suitable for just one power mod, and you may need to take several power mods and use them in parallel. The Xgen has been specifically designed to allow you to do this. In the example that we're talking about today, we are going to take 4 XG4s, each set to 24 volts, to deliver over a kilowatt of power to your needs. So the example that I'm showing here is for our 3 XG4s already pre-programmed to 24 volts. And I'll talk through the step-by-step process that's involved on the 4th module. So the first thing that we need to do is that we need to turn the iShare switch on. You notice here we have a dip switch on board with an iShare either on or off. And once you turn the unit into an iShare mode, we change the unit to operate in voltage droop current share method. So once you've done that, you then take your module and you insert it into the chassis. You then attach your earth screw like so. And again, this is for mechanical stability and it's also for EMI purposes. Once you have that set up, you can then take one of the pre-prepped parallel links, and you note here that this has been specifically designed to fit exactly the space between adjacent modules. So once we take the earth bar, and it's important just to focus on the earth bar for now. So what we do is we connect that, and once we have those connected, we can then go ahead and turn on the power mod and set the voltage accurately. The reason why we ask you to set the voltage accurately is to improve on the current share. So we go ahead and turn the module on. You'll see here that the 4 LEDs are turned on. And as I've mentioned already, these have already been preset to 24 volts and have gone through this step process. So we firstly attach the earth link here. We then measure the delta V between the adjacent modules, and we try to get that below the 10 millivolt range. In doing so, we can get a plus and minus 1% accurate current share. So you'll see in this case, we have a delta V of 1.7 volts. So I'm going to go ahead and trim the voltage up by means of the trim pot here. And you'll see there that the delta V is now dropping. And you'll see here, the delta here is less than 1 millivolt between the adjacent modules. At that stage, you have now set the voltage correctly. You turn off your power supply and you attach the final link. And the unit is now set for parallel mode. So let me show you the theory behind the practice. The output stage of the Xgen series is a synchronous buck controller. Now, as I draw it here, I'll note that under normal operating conditions, we have a very high DC gain, which means we have a very tightly regulated output and a very low load regulation. So what I'm drawing here is the freewheel FET and the forward FET of the output stage, Q1 and Q2, and the output bulk capacitor. Now, one of the things we do with the Xgen is we have a current sense resistor on board on the return pat. Now, this current sense resistor allows us, by means of a differential amplifier, to understand exactly how much current each power mod is sourcing at any given time. And when you hit the switch on the iShare, what we do is we take a portion of that control, and what we do is we add it to the main feedback loop which sets the duty cycle for Q1 and Q2 to set the output voltage. So I'm going to draw it here. This is your switch. And we feed a portion of that back into the main control loop. The result is the more current that a unit delivers to the load, the more information that we feed back into the main control loop, and we trim back the duty cycle accordingly. So its output voltage will drop. The net result of this is that if you have several modules in parallel, they will eventually reach their equilibrium point, and current share will be based solely on the output voltage set point accuracy of each module.